Okay, for the next section, we are going to go to Chapter 2, Section 8. And this section is very similar to what we were doing when we were graphing lines in slope-intercept form, except now we're graphing inequalities. Okay, so if you look here, Chapter 2.8, graphing two-variable inequalities. And if you remember, inequalities are symbols like less than, greater than, less than or equal to, greater than or equal to. Okay, basically, instead of an equal to sign, we're now using inequality symbols. And if you think about what the word inequality actually means, it means not equal. So all of these mean not equal. First thing you need to know is the boundary line. The boundary line is a solid or dotted line where the shading starts and stops. Okay? A solid line indicates that all the values on the line are also solutions to the inequality. So if you draw a solid line, that means the line is actually included in the solution, okay? A dotted line indicates that the values on the line are not possible solutions. Use these symbols, less than or greater than. So a solid line means we have less than or equal to, greater than or equal to, and a dotted line means we have less than and greater than. All right, now let's move along and ask ourselves these questions. First of all, is the line solid or dotted? Solid, dotted. These are my symbols for solid and dotted. And is the shading above or below the line? Above the line is greater than or equal to. Below the line is less than or equal to, and we'll talk about that here in a minute. So here's my first example, okay? I have y is less than x minus 2. So think to yourself, when we graphed actual equations and we created that boundary line, we needed an intercept, a y-intercept, and we needed a slope. So we're going to use those exact same things, the y-intercept and the slope, to graph the boundary line. If I look at this, y equals, if you remembered, we'll go back and we'll think about y equals mx plus b, okay, where m was my slope and b was my y-intercept. So if I look at this one, there's my b, okay, -2, or if you remember, it has to be a point, 0, -2, and my slope is in front of the x, and since there is no number there, we're going to say there's an imaginary 1, so slope is 1. So to graph the boundary line, I have to start at 0, -2, which is right here, and my slope is 1, which means I'm going to go up 1 to the right 1. So up 1 over 1 here, okay, and that's going to be my line. Now, the problem is I can't just graph a line because I have to first find out, is that boundary line solid or dotted? And if you look back in your notes, and you should write these down so you don't forget, okay, oops, too far. A solid line means there's an equals to, okay? Do you see those lines underneath? A dotted line doesn't have those, so you can't, that's when you draw a dotted line. Well, if we look at our actual example, okay, since we have less than, that means we have a dotted line. So I'm going to go ahead, I'm going to use this dotted line. When you graph, you're going to do it on Math Excel. You're also going to make sure you use the dotted line. And it looks like this. So now I have to think to myself, where are the y's less than that line? Well, that's when you have to think I have to shade below the line because we have a less than symbol, okay? Look back and we have below the line. So to shade below this line, sometimes it's difficult. So I always think to myself, do you remember when you were back, maybe you still do this, I still do this. When you were a kid and you used to draw this picture, okay, you drew like mountains and you drew a sun was over here, you drew this sun, okay? When you drew that picture and you were a kid and you drew the mountains, okay, this is the mountain and this also stands for below the line. So if I were to use this line right here to draw a mountain in that kid mountain picture, below the line is going to be the actual mountain and not the sky. Okay, so when I go to shade, I want to make sure that I shade down here, and that is the answer. All these values down here are possible answers to this inequality. So the number 1, 2, 3, 4, 5, -2 is a solution to this inequality because it's in the shaded area. Okay, let's do another one. Okay, y is greater than or equal to 6x plus 1. Well, what is my y-intercept? Because that's always where I start. I start at my y-intercept. So I'm going to start at 0, 1, because 1 is my y-intercept. And I'm going to go to 6 as my slope. Okay, so 6, or if you remember to write it as a fraction, it's also known as 6 over 1. So we're going to go up 6 over 1. So start at 0, 1. I'm going to go up 6, 1, 2, 3, 4, 5, 6 units over 1. Okay, now am I going to draw a solid boundary line or a dotted boundary line? Well, if you look back at your notes, this means down here that this equal to sign means this line is actually included. So I'm going to draw a solid line. So that is a solid boundary line right there. It looks different than the one earlier because it was a less than symbol. Now this one is greater than or equal to. So if you think about it, greater than or equal to, I'm going to shade above the line. So if this were my mountain picture, like when I was a kid, and this would be part of it. For example, I'll just draw, like if I were to draw that mountain, down here, this side would be the mountain, right? This side would be the sky. So since it is greater than, I want to shade the sky. And I'll even go ahead and I'll shade it blue for the sky. Okay? So all of these values over here are greater than or equal to 6x plus 1. Okay? Y is greater than or equal to 6x plus 1. And the actual line is also included because it is a solid line. Okay, so make sure you think about that. Is 0, 1 a solution? Yes, because of the equal to symbol. Is 1, 7 a solution, this point? Yes, because it's equal to. It's on that line. If this line were dotted, the answer would be no. Let's try another one. All right, for this one, I have to graph. I don't know the slope and the y-intercept, so I have to solve for y first before I know what the slope and y-intercept are. And we have done this. We did this before Christmas break, so we are going to go ahead and solve this. You should know how to do this. I'm going to subtract x. Oh, I need to change that. Subtract x, okay, from both sides. And I have 3y is greater than negative x plus 3, and then I'm going to divide by 3. And if you remember, I'm going to distribute the 3 into each part. So I have negative 1 over 3x plus 3 over 3, or also 1. Now let me walk through that again, just so we can remember or review. I'm going to get y by itself. So I'm going to subtract x, okay, from both sides. So that gives me 3y is greater than negative x plus 3. And then to get rid of the 3 and the y, I'm going to divide and then distribute. Remember, negative x, there is an imaginary 1 in front of that x, or not imaginary, there's an invisible 1 in front of that x. And so we're just going to use that and put it over 3. And this one is 3 divided by 3, which is 1. So my y-intercept is 0, 1, and my slope is negative 1/3. Okay, that right there is what I'm using. Okay, y is, keep writing on it without touching it. Y is greater than negative 1/3 x plus 1. So I'm going to start at 0, 1 again, and I'm going to go down 1 over 3. Down 1 over 1, 2, 3. Down 1 over 1, 2, 3. And you can just make 1 dot or 2 dots. On Math Excel, you only need 2 dots, and then you'll connect the line to that. So I'm going to go ahead and make a dotted line since it's a greater than symbol. I'm going to make a dotted line since it's a greater than symbol. Uh-oh, it's not going to help me. Try that again. There we go. Okay, and there we have it. Now I have to shade. Okay, if you don't shade, Math Excel will mark it wrong. You have to shade because it's an inequality. So now that I have to shade, I have to think to myself, am I shading the mountain or am I shading the sky? Above it or below it? Well, since it's greater than, I'm shading above it, which means I'm shading the sky. If this were a mountain, okay, this would be the mountain underneath, and this would be the sky, so I'm going to shade the sky since it's greater than. Okay, I'm shading above the line because it's greater than. If you look back at the first page of the notes, above the line is greater than. And there you go. That is the solution to that graph, to that inequality. Now, decide if the point is a solution to the inequality. I'm only going to do one example for this one, so make sure you pay attention. Is this a solution? Well, how do I know? Well, if you remember x and y in my point, this is x and this is y, I'm going to plug those in for this x and this y and see if it's true, if it works or not. So I have 7 times 1, because y is 1, plus 2 times negative 1. Oh, I'm sorry, I messed up. I'm backwards there. My fault. You start over there. Okay, make sure I plug in the right points here. Okay, x is negative 1, so I'm going to put negative 1 in for this one. Y is 1, so I'm going to put 1 in for this one. Okay, my fault. So 7 times negative 1 plus 2 times 1 is greater than negative 5. Well, is that true? Is negative 7 plus 2 greater than negative 5? Negative 7 plus 2 is negative 5. Is negative 5 greater than negative 5? No. Negative 5 is equal to negative 5. So the answer to this is no. And you will have those on your Math Excel, so make sure, plug them in. If it's true, yes. If it's not true, no. All right.